Okay.
Good evening, everyone. Welcome to Advanced Course in Drones and Development, and I welcome you all to yet another masterclass. Today, we are going to have Uttam Pudasaini. Uttam Pudasaini is the co-founder of NAXA, which is a GIS-based startup in Nepal, and he's also the director of Nepal Climb Labs. He has been doing an amazing work in Nepal, and today he's going to be sharing his story and his work in maps, mapping, and much more with us today. So over to you, Uttam. Thank you.
Thank you, Dr. Ruchi. It's always a pleasure working with you and talking to your group of students from all over the world in this very interesting program. So hello and namaste everyone. I hope all of you are doing safe and then staying safe at your home. So today in this session, I have with me my colleague Sweta Khanal, who is a GIS officer by profession. So Sweta and me will be with you all today for another 1 or 1.5 hours. And during this time, we'll be sharing with you, we will try to share with you, what mapping is, what are the different types of maps, and how maps could be used in disaster management. And likewise, in the second session, we will talk more about how open mapping can be carried out using open source platforms such as OpenStreetMap. So the first session will be more theoretical, while in the second session, we will be doing some practical exercises as well. So before I talk about the technicalities and the types of the mapping, I would like to begin with sharing a very interesting and a relevant story to the current context. So, back in 18th century, I would like to take you back to that time when there was similar to the current context, like we have corona at the moment. Back at that time, there was a cholera flu, cholera problem, like cholera pandemic all over the world. And Britain was one of the country that was suffering the most due to the cholera pandemic. And there is an interesting story how mapping changed the perception and understanding of people and also the medical professionals regarding the cholera spread back at that time. So, what happened was this is a small place, a small town in London. And as you can see on the map, you can see there are some black spots around, which is also written as pumps and the black dots. So in the center of my screen, you can see a black dot. So those are the pump locations in the communities. And you can see some piles of coins like structures in the multiple locations. So, what happened was back at that time, the understanding was the understanding among the people and also the professionals was that cholera, it's a airborne disease. So everyone used to think, cholera was a airborne disease. No one knew the actual cause behind how the cholera is spread. So there was this Dr. John Snow from UK. So Dr. John Snow, what he did was he came up with the idea of creating a pictorial representation of what was happening on the ground. So he plotted all the pump location in the neighborhood as black dots on this kind of graphical image. And all of the death incident he plotted as the piles of coins like structure in the map. So in the map you can see, the areas which are location to pump, they have these huge piles of these kind of structures, while the area which are far from pump, the height of those structures is not that much. And after that, they came to a conclusion that cholera was not an airborne disease, but it was being actually spread from water, because the visualization in this graphical form, it gave a conclusion that um, you know uh, those locations which are nearby the water pumps, they have the highest recording of the death incident. So this was how a graphical representation in the form of a map changed the perception of the people all over the world. So yeah, this is the story of how a map changed the world during a time of a pandemic. So to define a map, there are like different definitions of what a map is. But to give you a very basic definition, as you can see on my slide, there are three different types of pictures. And if you look at these pictures closely, all these three pictures, they are the graphical representation of ground reality in different manners. So for example, the first picture, it looks like a plan. It looks like, like there are different road networks, there are forest areas, there are landmarks on it. The second picture on the top right, it looks like a drawing from a painter or a drawing from someone who has graphical skills. And if you look at the third picture more closely, it looks like a 2.5D, what we often call as, a perspective view of the real world. So all these three pictures, more or less what they are doing is they are representing certain geographical phenomenon. So, the third picture is showing the urban city. The second picture is showing a rural landscape. And the first picture is showing a plan, and it's showing a topographical condition of a certain location. So from these three pictures, we can derive the definition of a map. So a map, it's often termed as the spatial model of the real world. So that means, a map, it's a graphical representation of reality where the objects, they are reduced in a certain scale, and then they are represented in different medium. So the medium, it could be a 2D plane and graphical image, or the medium, it could be a 2.5D or a 3.5D image. So basically a map is a simple graphical representation where the objects are represented. And one thing that we need to understand is a map represents the reality, but a map is not a reality in itself, because the purpose of the map, it determines what kind of information we put in the map. So oftentimes we call map as a representation of the reality. It's not a reality in itself. So this is like a very basic, definition of what a map is about. And if you go and look into, if you do some research, the word map, it comes from the medieval Latin mappa mundi. So that's a terminology, and that terminology, it means, in that terminology, it's a Latin word. So mappa, it means napkin or cloth, and mundi, it means the world. So before, in the ancient time, people used to draw these pictures of the world in cloths or napkins. So that's how the terminology map, it came in the ancient period. Just for your knowledge. And if you look at any map, whether it's a computer map or it's a hard copy map, there are different components on a map. So this is a very typical example of a common map. These days, like people are free to create any kind of map, and it's not necessary that every map has this kind of elements. But if you go into the basic definition of a map, these are the major components in the map. So on the top side, you can see the title. So every map, they needs to have a title, and every map, they also needs to have information regarding the coordinate system. So as you can see on the map, like every map, it has information regarding the coordinate system, which coordinate system that particular map is based in. And also, since a map gives information about location of the object, the north arrow is mandatory. So whenever you are creating a map, you need to also put the north arrow, so that your audience or the user will have an understanding about the orientation of that particular place. So you might have noticed in all of the map that we use, there is an arrow on the top. So even in Google Earth, there is a north, south, and east west directional arrows on the top. So the north arrow, it helps to align the map in a particular orientation. And likewise, scale is another major factor in any maps, because as I mentioned earlier, the objects on the ground, they are represented in certain scale. So not all maps have similar scale. Depending on the purpose of the map and depending on the size of the paper, different map, they have different scales. And another important component of the map is the information regarding the authors. So who prepared that map, and the organization and those kind of details. So authors information is also considered very important in a map. So beside all these different components, one of the key component of the map is the legend. So what we do during a map creation exercise, we create a map, and then we design different symbols for different objects shown on the map. So for example, in this image, you can see, like there are some triangular structures. there are some irregular shape polygons which have green boundary, and then there are yellow. It is filled with yellow color inside. So to represent these objects, there is oftentimes this small section which is called as legend, and in the legend we put information regarding what those triangular structures are. So these are just for your understanding the basic components of a map. And whenever you design a map or prepare a map, this component is considered to be very important. So another as I said in the beginning, this is a very basic class where I'm going to share with you from very basic what are the different types of the map. So I think it's very important for you to understand these two different types of the map. So the maps, it can be classified based on the interactivity. So for example, in the slide, you can, on the left hand side you can see analog map, and on the right hand side you can see digital map. So, just by looking at the picture, you can differentiate between these two kind of map. So an analog map is a hard copy map where you cannot do much interaction. So once a map is prepared, it's that's it. You cannot do any more modifications or additions. If you want to add any new components in the map, you'll have to do the mapping from the very start. So that's what an analog map is. But a digital map is the kind of map that we use in our digital application. It could be mobile or laptops, or it could be our computer. And a digital map is far more interactive compared to an analog map, because in a digital map, as a user, you can do a number of different interactions. You can zoom into the map, you can zoom out, you can pan, you can measure, and based on the functionality of the map, you can do a number of different interactivity on the map itself. So just to give you more detailed information about analog and digital map. So by definition, analog map, they are rigid form of maps where message is conveyed by the virtue of symbology. So there are different symbols placed on the map, and that's how it conveys the message. And likewise in the digital maps, the maps are often kept in a digital media, and also there are more interactive options according to the objective of the map. An analog map, as I mentioned earlier, they are measurable but not interactive. So this is quite interesting. So it means you can measure the objects in an analog map. So for example, if you get an analog map of your hometown, you can measure the distance between the two objects. You can measure the area. So you need to do that manually, but measurement is possible. But in a digital environment, you can just do it within few clicks. So you can just like create a polygonal area, and then you can like create a map of that area. An analog map is always very easy to integrate other data. So for example, you have the analog map of your city and you want to add, let's say, 5 hospitals. Then it's very easy, because all you have to sorry, in an analog map it's very difficult because the map is already printed, so you cannot add more details onto it. But if you look into a digital map, you can easily do that, because it's oftentimes it's stored in a digital environment, so you can very easily add any new components into the map. So these are like very common and very basic type of map based on the interactivity. And one, this is another very critical and very important thing to understand when we talk about how we represent the real world in the form of maps. So I don't know if you have taken a GIS class before, but whenever we represent any object in a map or in a GIS environment, there are often two kind of data representation model. So we in the technical term we call it vector data representation model and raster representation model. So just to give you a very basic example, in the figure you can see there are two different images. The left hand side, it says it's a vector image, and the right hand side, it's a raster image. So the vector representation of the real world, it means, as we have studied in our coordinate geometry before, so all the objects on the ground, they are plotted like we used to plot in the graph paper. So back in our college days, when we used to study this geometry, we used to plot different coordinates on a graph paper, and then we used to draw, okay, this point is as xy distance from the origin, right? So a vector representation is that kind of representation where you represent the geographical object in the form of coordinate points. So for example, on the right hand side, you can see an image. So that is the real world you can see. And the real world, they are represented as a combination of XY points. So the river, it's represented as, series of different XY coordinates. And there is a small pond in between. And the pond is represented as a closed boundary, which you also call as polygon. So, in a vector representation, there are three different formats in which the data can be represented. So either we represent any geographical data in a point format, or we represent that in a line format, or it could be a polygon format. So anything when we are doing the mapping, the only way we can represent any object on a map is through these three different formats. You either draw a point, or you draw a line, or you can draw a polygon. That's how you represent the map under the vector representation format. And likewise, there is another representation which we also call as a raster representation. And the very best example of raster representation is Google Earth, or even the photograph that you take from your mobile phone. So if you remember using a very cheap mobile phone, and then like compare the photo that you capture from a very cheap mobile phone versus the photo that you capture from a good mobile phone which has a very good resolution camera. So one thing that you can see easily differentiate is the photo that you take from a cheap mobile phone, it's often pixelated. So there are multiple different boxes, and as you zoom into the picture, you can clearly see those different boxes. So that is what we call raster representation. So in a raster, what we do is, as you can see on the right hand side, we divide our area into different pixels, and every pixel they have a certain value. So for example, there is a building. So this is a real world. On your left hand side in the screen, this is a real world. There is a building in the real world, and also there is a road on the real world. So when you are mapping in a vector format, you just draw the coordinates. You just join the different coordinates and you represent the building. And if you have to draw the road, you just draw a polyline, and then that's how you create the road. But if you want to do the same thing in a raster environment, you have to draw different pixels, and each pixels it has different values. So as you can see here on the right hand side, e- every pixels they have certain values. So right now the pixels having the green values, they represent the building, and the pixels that has red values, that represents the road. So this is quite tricky to understand, but one thing that you need to understand is, whenever we are working in a GIS environment, there are two ways we can represent the data object, either through vector approach or through the raster approach. So that's the only thing that's important to remember. So those are the maps, the two maps that I showed to you earlier. Those maps are there based on the interactivity. So having limited interaction or having more interaction. But now I'm going to talk more about what are the different common type of maps that we use in our daily life, or what are the most common type of map that exist out there. So there are five or six types of this kind of maps. So the first one is the political maps. So the political maps, it's a map that shows the boundaries between the different countries and the different states. So if you see this kind of maps in future, then you have to remember that this is a political map, and this has a different purpose. It's showing the boundary between the different countries. And likewise, there is another map which we call as topographical map. So, a topographical map, I don't know how many of you have used this map before, but as you can see on the right hand side, it looks very congested. There are several lines on the map, and then there are also, like several polygons. So a topographical map is that kind of map that shows the topographical condition of a location. So it could be where the objects are located, where are the buildings located, where are the health facilities, where are the road network in that location located. And also the topographical map, it particularly shows the topographical undulation. And there is a particular kind of representation which we also call as contours. So we spell it as CONTOURS. So all the lines that you can see on the topographical map, these are the contour lines. So in a topographical map, by the use of contour lines, a topographical map, it shows the height information or the elevation information of any particular location. So for example, in this map you can see, there are different numbers written. So it says 1400, it says 1478, and then there is another line that says 2060. So every lines on the map, it means a certain elevation value. So this line, it is 1400 elevation value, and if you go one line above that line, then it could be 1420, and if you go one line further, it could be 1420, 60, 80, and like that. So that's what a topographical map is. And as an engineers, or as a professionals in the coming days, you might be using this kind of maps a lot whenever you are doing any project design. So it could be a road construction design, or it could be a hydroelectricity project, or it could be any other developmental project. A topographical map is very important because it tells you how much of amount of land surface needs to be excavated, or how much of land surface filling needs to be done whenever you are planning any kind of developmental project. So it's very important to understand the meaning and application of a topographical map. And likewise, there is another kind of map, which we also call as like the thematic map. And there could be several kind of thematic map. So for example, these days, we have been seeing this kind of map where the number of COVID cases in the country is plotted. So it could be a thematic map which is talking about the theme COVID cases in Nepal. And likewise, on the left hand, on the center of the screen, you can see a travel map. So this map is talking, or is giving you information about a specific theme, that is the travel routes. So what are the locations in that community, what are the road networks, where are the road network is spread in that community, and those kind of thing. So that's the travel maps. And on the left hand side, there is another kind of map which is giving information about the land cover. So all the green area in the map, those are the vegetation area. All the yellow areas in the map, those are the cultivated area. So depending on the theme of the map, depending on the purpose of the map, there could be several kind of the map. And then these four map that you see on the screen, those are only some representative sample maps, and then there could be several other theme. Okay, so these are basically the three major categories of map that you need to understand, and all other map could fall inside the thematic map category. So now let me talk a little about why it is important to know the map literacy, or why it is important to have similar to digital literacy and other kind of literacy, why it is essential for us to build the map mapping, or map interpretation skills. So I'll give you a few examples to understand why it's very important to have the map literacy skill. I think I don't know if you all are aware about, these kind of, if you have seen this kind of maps in your home, but based on my own personal experience, whenever we go to open a bank account, and whenever we are filling this information in the our application, and the guy or the lady over there, they ask us to draw a location map of our area. And I used to wonder, like why they were collecting my location information. And then later on I realized that the location information is very critical for the bank, because in the future, if they have to trace me, if they have to identify my home location or my office location, they can just follow that map, and then they can trace me. So the map making skill is very important, because if we do not draw our location map properly, then the bank or any other institution, it will be difficult for them to to identify our home or our office address. And also the same map can be used when we organize any events. So for example, if I am organizing a training in Kathmandu, and I need to invite professionals from multiple locations, then oftentimes what I do is I share with them, either I share with them my location coordinate, or the very easy thing is I draw a map of my event venue, and then I keep it on my browser. And that's how the people, they will be able to navigate me, and then find my office. And likewise, on the top hand side, on the top on the top part of the screen, you can see two different kind of map. I'm not quite sure how many of you have how many of you regularly interact with with your parents about your land property, but these are the land parcel map. And I'm sure that every person that owns a land, they have this kind of map at their home. And this kind of map, it provides information about the area of the land boundary. So as I mentioned earlier, that there are two kind of map that you are seeing in the screen. The first one is talking about the theme land area, and the second one it's talking about the theme location of a place. So it's very important for us to have the map literacy skill, so that we can understand and interpret how much land area we own. We can understand and interpret whenever we are invited to any location, to accurately find that place and attend the event properly. And likewise, there is this another map which was very popular during the first pandemic and during the first lockdown all over the world. So I am quite sure you all know about it. This is a Corona map, COVID map, prepared by the Johns Hopkins University. So the mapping is also very important because it's a very powerful means of visualization. So if you want to show anything, I don't know like the educational background of most of the participants in this group, but based on my guess, what I can say is, if you are an engineering student, you can visualize your engineering projects more powerful with the help of map. If you are a student of social science, you can identify and visualize the social science problem much more effectively through the use of maps. And if you are a medical student, you can plot the location of the health facilities, and then you can do a tons of different analysis by the use of maps. So that's why it's very important for us to have the map literacy skills. And there are other very simple areas where maps and mapping is very important. So for example, if I invite any of you, if any of you needs to find my office, and I ask you to come to my office for another training, then how will you find me? You will either like go to the online platforms such as Google Maps or OpenStreetMap or any other kind of map, and that's how you navigate to my location, right? So one of the very popular use of the maps is in navigation. So whenever we have to find a new place in a new location, all we do is we just go to Google or OpenStreetMap, we search the location, and that's how we identify that particular location. So that's one very important application of the mapping. And likewise, as a student, I very much understand the importance of location map. So, no matter whatever is my educational background, it's always very important for us to show the location where we are working. So location map is another very popular and most common application of map that's needed for any research or any study purpose. And as I said earlier, not only in visualizing health related changes, but maps could be a really effective way to communicate change. So, for example, oftentimes we hear people saying that Kathmandu is rapidly urbanizing. It's changing a lot. The building density in Kathmandu is changing a lot, right? We hear this kind of information. But how we visualize that information? And the answer is by the means of maps. So as you can see on the map, if you look at the map of Kathmandu in 1989, the red dots on the center of the maps, those were the only building footprints, and all the other area, it used to be either cultivable land or forest area, or open areas. But slowly with time, what happened was, more and more people started coming into Kathmandu. And now if you look at the map of 2016, sorry, I don't have the map of 2020, but if you look at the map of 2016, it shows how rapidly Kathmandu is urbanizing. So, even in your research in the future, or in any study that you do in the future, maps could be the very effective way to visualize how change is happening in any locations. So that's another application. And then there is, this another application of map, which I think is very important. And this is also very related to my today topic of presentation. So how maps is relevant in disaster risk reduction and management. So to give you like I have listed out some most common example of how maps could be, interesting in disaster risk reduction and management activities. So before going into those individual applications, I would like to share this interesting image that I found on internet. So a disaster risk or disaster management cycle, it has multiple activities within it. So if you look at the center of the screen, it says it's a disaster management cycle. And if you look around the disaster management cycle, there are four different activities. So it and the four major activities of a disaster cycle, they are like preparedness, response, recovery, and mitigation. So any disaster incident, it has these four different phases. And today I'm going to share with you specific examples that would be relevant in these specific cases. So it could be like what are the importance and applications of the map in preparedness, what could be the application of the maps in response, and how mapping could be used in recovery and mitigation. So I'm now going to share some basic examples of it. So to start with, how maps could be utilized in the preparedness phase. So this is a map of Kathmandu Valley, and this map has got, if you look closely in the map, you can see multiple colors. So there are some red zones, there are some green zones, and there are some different other colored zones. So and if you look and on the right hand side of the screen, on the bottom right hand side, as I mentioned to you earlier, there is a legend section, and the legend, it gives you information about what that color represents. So the green areas, they are the areas which are considerably very safer, and the red areas in the map, those are the area where there is high risk. So it could be risk of flooding, or it could be risk of fire, or it could be risk of earthquake, and different other kind of hazard. So if we do this kind of multi-layer mapping before any disaster incident, what we can do and what our city authorities can do is they can identify the safe locations in the community, or they can identify the safe locations in the cities, and they can make the recommendations to the city department council that only those locations needs to be utilized for settlement purpose. So if you build houses, or if you expand settlement in other location, then every year you will have to suffer, whether you suffer from flooding or you suffer from other kind of activities, you will always have to suffer. So at the at the preparedness level, or prior to any disaster, if we do this kind of mapping, we can give a strong evidence to our authorities through the means of effective visualization in the form of a map. So this is one interesting example. And likewise, this is another example from one of the project that we did earlier. So prior to any disaster event, what we can do is we can identify the humanitarian open spaces, and we can properly map them. So you might have heard about Nepal earthquake. So what happened in Nepal was, back in 2015 we had a big huge earthquake, and a lot of people, they came outside of their house and they started living in the open spaces. And one major realization to both authorities and government was, every cities, they need to have this kind of open spaces, so that it would be very useful during the disaster scenario. So if we are able to identify and properly map these kind of open spaces, then they become very useful later during the disaster scenario. So another importance of the map is, it helps the government plan this kind of preparedness activities through identification and mapping of humanitarian open spaces, so that they could be utilized at the time of emergencies. And likewise, mapping also helps the authorities to identify where are the risk areas located in their communities. And this is a map from one of our project in an urban municipality from Kathmandu, and all the dots on the map that you can see on the map, those are the location of landslide areas in the community. So these all dots that you can see, those are the landslide areas in the community. So through the means of map visualization, the community people, they can understand where where are the vulnerable locations in their communities, and how they should plan mitigation strategies, right? So this is how a map becomes very useful in the preparedness before a disaster incident happens. And likewise, maps are also very important during a disaster scenario. Again, this is another image map that was created during the Nepal earthquake. So what happens during a disaster is, during a disaster there are several actors on the ground. So there are humanitarian agencies, there are emergency responders, there are DRR responders, and there are a lot of people trying to do a lot of different activities on the ground. So what happens is, if you properly do the mapping of any area immediately after a disaster scenario, then this data becomes very useful for those kind of actors on the ground. So the humanitarian agency, they will identify, okay, these are the areas which needs immediate attention, and also they can identify these are the area which needs lesser attention. So they can focus, they can focus all of their interest in those areas which needs immediate assistance. So that's how maps become very important during disaster scenarios. And likewise, also based on the experience of the Nepal earthquake, what happened is, during any disaster scenario, what happens is, like, people, they often try calling the emergency responders. So if you are in a city area, that's fine, many people know your location. But if you are calling from a very remote area, and then like, for example, you are from a remote location of Nepal, and then you are calling a helicopter for your assistance, or you are calling an emergency rescue and evacuation in your area, and if you do not have a proper map of the road network, or if you do not have a proper map of where the helicopters could be landed on that location, then it hampers the emergency response activities. So the mapping is very, very important. As you can see on the left hand side, there is a village which I found on Google Map. The name of the village is Bocha. It's Bocha, and the green line is the road network that connects the Bocha village from the nearby road network. So before, so the green line, it does not exist on the map. I just created it randomly. So if the green line does not exist, then for the humanitarian responders who go there from Kathmandu, they will be in confusion. They don't know how to get to that location, and then it ultimately it hampers the rescue and relief activities. So mapping is very important. If you properly map all the communities, if you properly map all the critical facilities, then it's become very useful for the disaster responders at the time of emergency. So that's another importance of mapping. And likewise, mapping also helps in accurately estimating the damage. So for example, let me give you another scenario. For example, there is a flood, there is a huge flood in Nepal, and also the flood it reached India. So there is a huge flood, and now the government, they want to estimate how much amount of land area is currently inundated, or how much how many buildings were displaced because of that particular flooding scenario. So all this kind of visualization and analysis could only be done with the help of mapping. So as you can see on the left hand side, the red line, it's a river, let's say, and on the both side of the river is the extent of the flooding. So up to that extent the flooding has reached. And through this kind of map, what you can do is, in the GIS platform, you can do an overlay analysis, and you can overlay the river network over the another area which shows the affected location, and through that overlay analysis you can accurately estimate what amount of land area has been affected, what number of total buildings have been affected. So all these kind of questions you can easily get from this kind of mapping overlays. So that's why your map is very important during a disaster scenario, because it provides this kind of information to the authorities. So these are some examples that tells you how map is important before and during the disaster. And now let me go into one or two examples how map could be useful in a post disaster scenario. So I found this very interesting image of a city area. This is the exact location. So before, it was affected by, I think it was affected by hurricane and by a tornado, and on the right hand side is the same community that was built after the tornado. So a mapping, it also helps in creating a reconstruction plan of a community. So whenever any community is affected by disaster, you can begin a new mapping, and then you can plan where the service facility needs to be placed. You can plan where the settlement needs to be expanded. So all those kind of planning in a post disaster scenario you can do with the help of mapping. So this is all about the different applications of mapping, and this is only very basic. As I mentioned earlier, there are huge applications of mapping, but the examples that I shared with you, those are only very basic example of the mapping. So now I'd like to go into the second session of our training today, which is about how we do the mapping. So all this time you heard me talking about what are the different applications of the mapping, and how mapping could be used in a different purpose. But if you want to know more about how to do the mapping, I have like 2 or 3 more slides remaining, and then my colleague will give you practical information and also practical session on how we do the actual mapping. So based on the existing practices, there are numerous different ways on how we collect the map data. So the first and the very basic way is through the field measurement. So we take the GPS device, we take the mobile device or any other kind of measurement device. Then we go to the field, we capture the coordinate information in different format. Then we come back to our office, we input that coordinate into the mapping software, and that's how we create the map. So that's one way, that's one method on how we do the mapping. And likewise there is another method. This is the field measurement method is not only limited to a limit when you do a mapping for a specific area, but there is another approach which we also call as photogrammetry and remote sensing. So if you need to map an entire country, or if you need to map an entire city, then maybe the field measurement could not be possible. So in that case, what we do is the satellites which rotates around the earth, those satellite, it captures the information, or it could be also drones, drones flying over the earth surface collecting the information. So the second way is through the use of this kind of remote tools and technologies. And now, what's more relevant to our today's topic and what you will be learning in the upcoming session is two different kind of mapping initiative, which is very popular all over the world. I'm sure all of you know about Google Maps because we have it by default on our mobile phones and mobile devices as well. So right, we use Google Maps for a number of different purposes, but very similar to Google Map, but the modality and all the functionalities are quite different. There is another mapping initiative which is also called as OpenStreetMap. So the OpenStreetMap, it's a very interesting initiative. It's an open initiative. So now I'd like to request my colleague Sweta to talk more about what OpenStreetMap is, how we do the mapping using OpenStreetMap, and also do a small short exercise where she will be leading you, where she will be teaching you how to do the mapping using OpenStreetMap. Sweta, so over to you. I'll stop sharing my screen, and if you have any questions, we can maybe take it towards the end of the session.
Thank you, Uttamji. Okay, so I will share my screen. Okay. So hello everyone. I'm Shweta Khanna. I'm a GIS analyst from NAXA. So today I am here to talk to you about OpenStreetMap. So what is OpenStreetMap? OpenStreetMap is generally known in GIS world as a Wikipedia of maps. I'm pretty sure that most of us know what Wikipedia is, and we frequent Wikipedia when we want any information about any place or anyone or any situation. Basically, we go to Wikipedia because it has most recent and a lot of information, relevant information that we would want about such situation. So similarly, OpenStreetMap is also kind of like a Wikipedia of maps because you can find very recent and relevant information about a location in OpenStreetMap. So OpenStreetMap is also a very participatory or collaborative approach of mapping. So what this means is that rather than being just a one person approach of mapping, it takes information from a lot of people, collaboration of a lot of people and all of their information, and it displays in the map platform of OSM. OSM is also free to use, which means that OSM data is not copyrighted or is not uh, costly, or I'm sorry, it's free to use basically. So what is open initiative of OpenStreetMap is that OpenStreet in the initiative of OpenStreetMap is basically a knowledge sharing platform. So what happens is in this is that we collect each and every one of us information about our localities or even other localities that we can gain from just remotely looking at the satellite images, and we plot these informations into maps, and that's how it's a knowledge sharing platform. So basically the principle here is that not everyone knows everything, but everyone knows at least something. So when we collect something from everyone, it becomes a very vast database of geographic data. And another initiative of OpenStreetMap is also data sharing. So OpenStreetMap is a very open source that is beneficial to many Nmap users worldwide, which means that you can openly interact with the map platform itself and also its data. So data sharing is the main and integral part of OpenStreetMap. So now that we know the basic principle of OpenStreetMap, I would like to move on to the journey of OpenStreetMap from when it started to till now. Excuse me for my voice. So OpenStreetMap has a very rich history actually. In 2004 in UK, the government conducted a very large survey, which was paid by taxes. So this survey was basically about basically collected all the road data of UK. It was a big survey and had a very vast database when it was done. So what was expected, since it was a big database and since it was tax paid, since it was paid by taxes, people generally expected that they would also get access to this data which was collected. But unfortunately, the government in UK could not successfully distribute it among the locals. So when the OpenStreetMap was open, it was open so that everyone can have access to geographic data, since it is such an integral part of all of our lives, and especially people who work in geospatial data. So it was found in 2004, and finally it was started in 2006, and it was established for the sole purpose of encouraging distribution of free geospatial data, so that the data would not cost anything to upload or would not cost anything to download as well. So this is the past of OpenStreetMap. And when we zoom into the present of OpenStreetMap, the OpenStreetMap platform has been doing so well that by 2021, a total of 76,25,100 registered users were voluntarily participating in providing data in OpenStreetMap. So the next question we are tackling here is, why do we actually use OpenStreetMap or prefer OpenStreetMap? So the main reason here being that OpenStreetMap is very neutral and transparent. It basically means that no data is hidden, or no metadata is hidden from general users, which means that if we want information about a certain location, then whatever data is there available in OpenStreetMap database is what will be provided to us, which is generally not found in all the mapping platforms, or rather in any other platforms, not just mapping platforms. So this is a very good initiative that OpenStreetMap took, and this is the main reason why people all over the world are now preferring OpenStreetMap over many other mapping platforms. So the next thing is that it's free and editable. So I would like to explain this with an example. So how many times have you felt like when you are navigating in Google Maps, how many times have you felt like this is leading to a road, but there is another road which is more accessible, or which is a shortcut, or sometimes there is even no road data in Google Maps, and it just shows a dead end when there is actually not a dead end. Or there are also other examples, like how many times have you seen that a certain name was incorrect in Google Maps, or certain information was incorrect in Google Maps. So what OpenStreetMap has done here is that it has made the data free and editable, which means that if I am going somewhere, if I am navigating someplace and I see any mistakes or any ununiformity in the data, then I can just edit it right then and there, which is very convenient for the users of OSM. So anyone can make edits and use the OSM map for free as well. Okay, so the next point why we prefer OpenStreetMap is that you can use, reuse, and redistribute data. Of course, I have mentioned in previous slide that OSM has no copyright on their data, and it is free of cost. So it also helps that as a GIS analyst, I myself use OpenStreetMap data a lot, and I can use it, reuse it, and I don't even have to provide any reasons of why I'm using it, or I don't have to take any permission from OpenStreetMap to use this data. So that is a very good initiative, and this is also a reason why OpenStreetMap is preferred all over the world. So the next, and it's kind of in sync with the second point that I made, it has very frequent updates, which means that there are a lot of people who are contributing in OSM constantly, which means that people are updating the data constantly, which means that we are getting very recent data, and which is a very reliable data. So in this images you can see that this is earthquakes data. So you can see in maps that when the earthquake strike, or it destructed a lot of buildings, then the data was updated accordingly in OSM platforms. Another reason why OSM is great is offline maps. OSM itself and many other supporting apps, apps that support OSM have functions for offline maps, which means that you can download offline maps and use it offline. You use it completely offline. But of course, there is argument that This is also available in Google Maps and other maps as well. There most often than not there is function of offline maps in many other mapping platforms. But having said that, in OSM, you can also make edits in offline maps, and then later when you come online, then your edits are synced accordingly. So here I want to show you a comparison between OpenStreetMap and Google Maps. So the one in the right side of the screen is obviously Google Maps, and left side of the screen is OpenStreetMap. You can see here that it's the same area, but the data available in OSM is way more than data available in Google Maps. Again, this is because there are a lot of people who are contributing to OSM continuously to make this possible. So we have talked so much about OpenStreetMap, but how do we actually map in OpenStreetMap? So the basic how we can map in OSM is by remote mapping. So what we can do is we can take devices that are used in remote mapping, like GPS, DGPS, and there are other examples that I cannot think of right now. So you can use these devices and take locational data, and then what you can do is later when you have access to internet, you can edit this data in OpenStreetMapping platform. The next, how you can map in OSM is also by remote mapping. So remote mapping is when you don't physically visit the place that you are mapping, and you rather rely on satellite images to map a certain area. Generally, this is how OpenStreetMap volunteers map most of the time, because OpenStreetMappers are generally from all over the world, which means that they don't exactly have the option of going on field whenever whenever they want to update certain data in OSM. So remote mapping is when you remotely update or map a certain data in OpenStreetMap platform. So after mapping, for mapping, we need certain editing tools. We need certain editing tools, and here I'm going to talk about the editing tools that are only available in OpenStreetMap. So the first I would like to start with the OpenStreetMap actually provides us two options. Here you can see that there are three options for edit, but this is a rather old image, and right now at this very moment you can only get two options for editing in OpenStreetMap. So the first one is ID Editor. ID Editor is an in-browser editor for OpenStreetMap, which means that you can just do it in whichever browser you are using. You can just open a tab in your browser and then start mapping in that browser. The next option, however, is a separate software. Okay, so from this image we can see that under the edit tab there are two other options, which are Potlatch and Remote Control. These are both actually a separate software. Potlatch is actually in browser, but it needs a separate software for support. So right now you can see Potlatch in remote control editing as well. So the next and the most generally used, especially by me, is JOSM, which is Java OpenStreetMap. So this is a separate software which is made for sole purpose of editing OpenStreetMap data. And also uploading the data. So as I mentioned earlier, you can also get the files from GPS and DGPS. So what happens is that in OSM ID editor, it's not very convenient. So for most of the frequent OSM users, JOSM is a very convenient tool that is regularly used for editing the data in OpenStreetMap. So how it works is there is a separate software which you can link with your OpenStreetMap account, and then whatever you edit in this software, it automatically updates in the OpenStreetMap mapping platform after it verifies your edits. So this is a very convenient tool if anyone is looking to contribute in OSM. I would definitely recommend the JOSM software. So the next thing I want to talk about here is very on theme with the previous slide, and that's disaster in OpenStreetMap. So it is a fact that the OpenStreetMap is mostly used for disaster response. And the example I would like to give you is again of Nepal Earthquake 2015. OSM mapping platform specifically in Nepal was not very well known till 2015. It's only after the disaster hit us that people became aware, especially GIS analysts or anyone who works in the field of geography knows this, that in that time of desperation, OpenStreetMap was extremely helpful for our situation. So specifically in Nepal 2015, what happened was OpenStreetMap made an initiative of mapping Nepal, and from then people from all over the world were constantly mapping in OpenStreetMap data of Nepal, specifically data where the disaster had devastated the most. So we can also see that in OpenStreetMap, if you see historic data, then we can see that the map of Nepal or data in Nepal before earthquake and after earthquake has drastically changed. While there was little to no data prior to that incident, right now almost every part of Nepal is mapped in OSM. Oops. So how do we, after knowing all this about OpenStreetMap, how do we exactly go on and start OpenStreetMap? Hello?
Sweta,
Okay.
are you going to now begin like showing the actual OSM interface?
No, I will show actual interface only after the slides complete.
Okay, thank you. Yeah, please proceed. Sorry.
Okay, so how do we start? Okay, so I'm just going to scan through all these remaining slides because I also intend to show all these steps in OpenStreetMap as well. So if it's a bit fast, then don't worry, I will definitely repeat this again. So how do we start OSM is, first we go to osm.org. Then a screen like this should appear. And then what you have to do is, on the top right, you have to sign up. So while you are signing up, you can see this kind of forms appearing in your screen. You just have to fill your information, and then this next page of information, and then what happens will you have to validate your email, and then you can proceed in OpenStreetMap. So after that, you can log in. So the next thing is OpenStreetMap interface. This again, I will explain it in the OpenStreetMap as well, but I'm just going to scan through these next slides. Okay. So in OpenStreetMap, we have a search. Of course, what mapping platform won't have a search? So, and the next thing is the toolbar. It's the most relevant thing for us is the side toolbar, and the rest is kind of not very relevant, and we do not use it just as much. So these are the only thing that I will be explaining further as well. So the next thing, okay, with this I will take it a bit slow. So what happens is, as I said before, OpenStreetMap is a world map. So it obviously has a lot of data, a high volume of data. So how OpenStreetMap maintains that data is through tagging. So what is a tag? We have almost, I mean, of course, each of us has seen a tag in their life at least once. So what is a tag? Is that is a label attached for identification and other information. So as we see that this piece of shirt has a tag which has information like MNS, and the others are blurred and I cannot see, but in the other images you can see there is tag of sale, there is tag of discount up to 75%. So these are the things that tags shows us. So similarly in OSM, what a tag is tag shows the basic information about a certain geographic data. So in this image, what I am showing you is this is an airport, specifically Bosang Airport. So how do I know it is the Bosang Airport? Is through the tags. So the first tag is Aeroway Aerodrome, which is the basic tag for airways in OSM. There is elevation ELE 1250. So this shows that this specific airport is located in 1250 elevation. So IATA and ICAO is actually code for the flights. Code for the airport. One is internationally recognized code, and the another is nationally recognized code. So, and the next thing is name, Bosang Airport, which means the name of this airport is Bosang Airport, and the source here is ourairports.com, which means that whoever edited this obviously took it out from ourairports.com. So this is the model of tag in OSM. So what we can see there is that a tag always comes in pair when it comes to geographic data, specifically in OpenStreetMap. So the pair is called key and value. So the basic formula is key equals to value, which means that key is a category or a subcategory of this data, and the value represents the specific data relating to this location. In this example, we can see city, Denver, state, Colorado, country, USA. So in this case, city is the category, which is the key, and Denver is the location specific value. As we can see, as this example is from prior slide. In that case, the major tag was aeroway equal to aerodrome, where aeroway was the key and aerodrome was the value. Some other examples of tags. So I have taken a forest, for example. So for forest, general tag, we have a general tag of natural equal to wood. And to be more specific, we can also use land is equal to forest, or if we know more information about what kind of trees there are, then we can also use wood equal to coniferous. So these are just the examples of how you could tag further in OSM. So that's it with my slide, and I would like to move on to actual OpenStreetMap platform.
Sweta, I just have some additional details to mention on what you just presented. So if you give me like 3-4 minutes.
Okay.
Okay. So yeah, whatever Sweta just briefed in her presentation, I think there are three important things we all need to learn from what she explained during this time. So the first thing is, there are two major platforms as Sweta mentioned. So one is Google Maps or Bing Maps or any other kind of mapping platform which is maintained by a private company, or which is maintained by a company that has for profit or business intentions. And OpenStreetMap is the only global initiative which is not maintained for any for profit purpose, but it is a map which is maintained by volunteers. So that means, I can map my community, you can map the locations around your home, you can map the locations around places that you have been to. So the main idea of OpenStreetMap is that it is based on the idea of crowdsourcing. So, the crowds, they provide information about what exists around their locality, and that's how the map is populated. So that's one thing which is very important to understand. And the second thing, when Sweta mentioned about the application of OpenStreetMap in disasters and many other contexts, and to give you a very practical example of that, so for example, a few months ago there was let's say let's consider, like few months ago there was a big flood or big earthquake in Nepal. So whenever there is any earthquake, any emergency responders or the government or anyone, they need updated map of that particular location. So the beauty of OpenStreetMap is, whenever there is any crisis situation all around the world, any volunteers from anywhere, they can contribute in mapping. So even people living in USA, people living in India, they can go to OpenStreetMap Nepal, and they can add buildings and they can add roads and they can add such other features, which is very difficult to do in other proprietary platform. So in a commercial application, you cannot, like map any, you cannot go to a Google map and do any changes that you can want. But in OpenStreetMap, you can do that very easily. So that's why OpenStreetMap is very popular, because it is maintained by the people. So it was developed for people, and also it is maintained by people. And a lot of people, when they know about OpenStreetMap, and they often start contributing in OpenStreetMap, because making your contribution on OpenStreetMap is like a digital volunteer activity. So sitting in India or sitting in Nepal, you can help for a cause in any other country. So for example, these days there is a flooding ongoing in Sudan. So Sweta will show you a platform where you can identify, or where you can search all the major OpenStreet mapping activities ongoing. So you can go to that platform and you can join any mapping initiative and you can contribute. So by sitting at your home, you can contribute for a cause such as flooding in Sudan, or it could be earthquake in Guatemala or any other country. So yeah, that's another very important thing we need to understand about OpenStreetMap. And the third thing which is very important is, any data in OpenStreetMap you can easily download. So for example, if you can view the data of hospitals, you can view the data of education facility in a Google map, but you cannot download that data for your purpose without any cost. But in OpenStreetMap, if you need data of anything for your research, you just select the area and you can download everything, because that was maintained by people like you. So these are the three important takeaways which you all, I think, need to very clearly understand from the Sweta's presentation. And I hope you will understand more when Sweta will be sharing her screen and provide the demonstration. Over to you, Sweta.
Okay, so with that, I would like you to I would like to take you to OpenStreetMap. So first, I would like to just show you the interface of how OpenStreetMap works. Okay, so the first thing we can see here is the search button. You can search any place basically, and you can also search from location. So if I search this location, then you can see that it leads me to the exact location. Okay, so the next thing is the stop bar. So the edit bar, we all have already talked about it. There is only two options right now, the ID editor and then the remote control option. So history is obviously to look at history, data history of this specific area. It will also show extended area as well. As you navigate through OpenStreetMap, you can see data for any other places that you would like. Then the export option is obviously for exporting the data, and export option is limited to the screen extent that you are in, and it won't export the data that is outside of the screen extent. So if you are trying to export data, then that is something you can keep in mind. Okay, so the side toolbar is so the basic zoom in, zoom out, show my location. I'm not going to show my location. Okay, so the next thing is layers. So the layers is a layer of maps that okay, so these are the options that you have right now. What's displaying in our screen is the standard OSM map. If you choose this, then you can see that the map layer is absolutely different. If you choose this, then you can see that differs from the previous map. This has a little bit of a 3D effect. This is specifically for cycling routes. And then there is transportation map. It does not show irrelevant data. It absolutely shows the road data, highlights the road data, and shows information about bus stops and maybe landmarks. So it is absolutely for transport map. And similarly, you can also navigate through any other maps. There are a total of 1, 2, 3, 4, 5, 6 maps. And as we navigate down, you can see that in the layers, you can see that there is a, okay, I'm going to standard map. Okay, there is a map of map nodes, public GPS traces, and map data. You can get nodes that are left by other OSM users, data, of course, and then GPS traces that was used to edit or that was used from OpenStreetMap application. Okay, so that's it with the layers. And then the next is map key. So this is a legend of the symbology of the map in its current extent. So as you can see, the more I scroll out, the map changes, and the map key also adjusts accordingly. So the more I come in, and the more feature it detects in my screen extent, and that are the only information that are being displayed in the map key section. Okay, so where was I? Okay. Okay, so going to the next tool is sharing. Of course, you can share the map with anyone, or you can share it in any platform through this link. The next is map node. So what map node is, what we can use map node for is, if we see any inconsistencies or any errors, then we can just drop a note, and then we can see that note from this layers pane. So these are the notes that have been left previously by other users. Okay, I will turn it off now. And the next is query feature. Okay, so let's let's do query of this structure. Okay, so what query feature does is that you can query any of the features that are available here. Okay, so my options according to where I clicked is the grassland, runway, taxiway, grassland, taxiway. Okay, so I would like to know about the runway. So what happens here is we are shown the identification of this feature, the tags of this feature, which is basically the information of this feature, and when it was edited last and by whom, and how many nodes does it have. You can see it if it's relevant to you. You don't have to see it if it's not relevant to you. So similarly, let's also query another feature. Okay, so let's query this school. So if I want to know more information about this school, then I can just go to the query feature. Okay, so school, I'm going to select the school. So what I can know from the school is there are 120 students in the school. Okay, so there are 30 personnel in the school. This is a private school. Its name, there is only one building in the school, and that's it. So if suppose I had information about the school, like its opening times or how till what level does it serve, like is it a basic school or higher secondary school, lower secondary school, then I can also add that in tag so that anyone who is interested in more information can also see. Also phone numbers and other emails, kind of like that. So this is the basic interface of OSM. Now moving on to how you can sign up in OSM. I was already shown the slide, but okay, so let's go to sign up. This is the page that you are going to, basically you have to fill this information, then you will get another page where you just have to agree to the terms and conditions. After that, OSM will send you a mail for email verification, of course, and then you just have to verify that email, and then you will be ready to log in. So let me log in. Okay, so now that I'm logged in, I would like to also show you how I can edit in OpenStreetMap. Okay, so if I want to edit this area, then I will have to. Okay, so you can see that the edit pane is gray when it's really zoomed out. It's because there is a lot of information in this map extent, and as I've said before, OpenStreetMap is basically a map extent kind of application. So you cannot access all data at once. You can just access, you can only access the data in your map extent. But obviously, since this map extent will definitely have a lot of data, and this program won't be able to load all this data at once. So we can only edit when the program is comfortable enough to load the data. So okay, so let me just, okay, so if I want to map this area, then I will go to edit. I will use ID editor right now. So okay. When you open this for the first time, there will be a walkthrough. So if you will try it out, then you can definitely get a tutorial, even if you log into this later. Okay, so what we can see here is the map that was showing in the actual home page of the interface is very different than what it is showing right now in the edit tab. It is because while we are editing remotely on basis of satellite imagery. So while the home page does not necessarily require a satellite image for us to scan through the data, editing tab definitely does require satellite data for us to check. So we can see right here that these buildings are not digitized. Okay, let me first show you how digitized buildings look. Okay, so this is the area. We can see the area in satellite image, and then this red polygon, I hope you can see it. This red polygon is the digitized form of area. So this is how digitized data looks like. So here, okay, so I was just in, I just have to zoom in a little more. Okay, so everything is basically digitized here. Okay, I think, okay, so this building is not digitized properly. So let me just show you in that. Okay, okay, so first let me also go through the tools that are available in editing tab, which is different, not entirely, but a bit different than the home page. So the main difference and what is actually important is this background settings. Here we can view a lot of imagery list. So right now we are using Bing aerial imagery, but if we wanted to change to suppose NAXA, which is NAXA is a good imagery for Nepal, and since I am here in Nepal area, so okay, so the Maxar and Bing, you can see the difference in data, right? Because okay, this is Mapbox satellite. You also have S3. S3 is not. I don't prefer S3 myself, but it absolutely depends on which area you are mapping, because satellite imageries are tricky, right? You have a lot of shadows, you can have clouds, so you just have to navigate through a lot of satellite data to finally settle in one for said area, and you will again have to scan through a lot of satellite images for adjacent area as well. Okay, so the basics of geography, as we know, is point, line, and a polygon, which is area. So point we can use to define any smaller areas. So we can see this is represented in point. This is a temple which is very small, obviously. That's why the contributor who mapped this could not make a polygon and opted for the point. So we can also use points for other discrete data like tabs, entries, but basically you can represent any area in point if that's what you prefer. But in OSM, I personally prefer to plot everything, most of the thing in area. So the next feature we can draw is a line feature. Line feature, as you can guess, is for the continuous data, like road, river, and similar data, like road and river data. I think that's it. I think. Okay, so let me just show you how I plot area. So I select this area tab and then I just draw over it. Further, as I've mentioned before, you always have to give tags in OSM. So how I'm going to tag this specific feature is, this is obviously a building, so I'm going to give the tag of building. So the tag for buildings is building equals to yes. But since I don't have any external information about this data, so I can just leave it at that. So what I'm trying to say here is that you don't have to know absolutely everything about a feature to draw it remotely. You can just contribute it as best as you can. So the main problem here, we can see that the polygons of OSM data and the satellite imagery don't exactly overlay with each other, and it's not in place. So why this happens is that generally we have a lot of imageries, and when someone is contributing, they can be using a different imagery to what I am using right now. So this can also cause a shift in the data. And also another thing is, sometimes when the imagery satellite image is being overlaid in a world map, in any kind of map, the exact overlay is not guaranteed. So this can be problem of data, this can be satellite problem of satellite image, we don't really know. So what we do is, we don't edit historic data, and we rather while we are editing, we just try to edit perfectly to what we are using right now. But what you can also do is check if this historic data was made in the same imagery you are using right now, and if not, then you can also go ahead and use the imagery that was used by the previous contributor and start mapping on that as well. Okay, so next thing is, obviously you have to save your changes by save. You can put change set comments here. I am just going to use mapping Nepal, and then add field sources. The source actually, what you have to put in sources is which imagery you are using right now. So I'm using Bing aerial imagery, so I'm going to use Bing. I would like someone to review my edits. There are tags for the upload, and then I can just upload. Okay, so this is the basic of how you map in OpenStreetMap. The next thing that I want to share with you is, as mentioned, there is this platform which helps in contributing. This is Hot Tasking Manager. This is specifically for frequent contributors. Okay, so let me just show you what it does. So you can explore. Okay. Difficulty level, I'm going to say beginner, projects to map. Okay, yeah, because okay, there are projects to map, project to validate. You can only validate when you are above beginner generally. It actually depends on the project that you are contributing to. The institution who actually published the project has the right to give you the access to validate. Sometimes, most of the times, the validation access is given to intermediate to advanced level of mapper. Okay, so I'm going to say projector map. Okay, so you can see there is migration crisis. You can contribute to this cause, or there are a lot of. So what you can see here, you can see that this is urgent. This is South Sudan COVID vaccination project. So let me just open one and show you the basic layout of the project. So the description is, as COVID vaccines start arriving in low and middle income COVAX participant countries, successful vaccination program depend on geographic data to help identify priority population groups. And if I say I want to contribute, I have a to log in, you can just use your OpenStreetMap account. So it is not a hassle. You don't have to create another account. Imagery. So you can see here that this project specifies NAXA beta imagery. You may switch to Bing or Esri, but the priority is this imagery. Fully mapped. Okay, so if the so existing map does not match imagery, this happens a lot when alternative imagery is better. Okay, so you can see that we are actually supposed to map buildings, roads and paths. Okay, so do not map roads and paths. It says specifically to not map roads and paths. So what we have to do is, I think, only building for this. There are certain guidelines given, and then there is change set comment. As I showed in while uploading the data, you have to put change set comment, and this is the change set comment for this specific project. So how you actually contribute is you can scan through. You can see that there are these boxes. There are these boxes. So these boxes are the areas that we are supposed to map. So let's say I want to map this area. Then I'm just going to have to select, okay, so ID editor or GeoSM, there are two options. So I'm going to go with ID editor. So map the selected task. So this is the box, and you can only map in this area, specific area only. Okay, but there is no feature in this, and we are only supposed to map the building, but we can see that there is no building. Okay, I think this is a building. So what I'm going to do is area. Okay, these are the buildings. So yeah, I think that those are the only buildings in this area, as far as I can scan. This is not exactly building. Okay, so since that's it, right? So what I'm going to do is, yes, this is completely mapped. Comment, if I had any comment, then I would, but okay, I think. And let me just upload this first. Also, you can see that the change set comment are embedded, and it automatically comes when the area has no descriptive tags. But okay, so it has no descriptive tags, but okay, so sorry, I forgot to give the building tag. Building equals, yes, and this building details here, and then I can upload. Okay, these are all things. Okay, upload. So now I can, after I have uploaded, I can submit this task. So I just contributed and helped in South Sudan COVID vaccination project, and I'm pretty sure this has to feel very rewarding to anyone. So with that, I think I would like to end this end my session. If there are any questions, then I think this is the when we'll take it. So thank you, everyone.
Sweta,
Yes. Okay.
I think it would be interesting for our audience to see, how we update point, line, and polygon on OpenStreetMap using ID editor. Josam will take more time, so could you so in 5-7 minutes go to OpenStreetMap and then log in, and or have you already done that?
I have already done that.
Oh, okay. So thank you so much, Sweta. Ruchi, I think we can go for Q&A round now. If our participants have any questions, because this was a short session definitely, and there were several things shared by Sweta. So if our participants have any questions, we are more than happy to answer. And Sweta will also provide multiple links to all of you after our call today, because there are so many learning materials available online on about OSM. So there is a guided tutorial that teaches you the basics of updating the OpenStreetMap. So we will share that to you. There are also so many wiki pages that has step-by-step guidance on how to do the mapping. So we'll also share those resources with you. But for now, if you have any questions, we can discuss about that.
First of all, I would like to thank Uttam and Shweta for your generous sharing of your knowledge and wisdom and your experience with maps, mapping, and even OSM. So thank you very much. I would welcome questions or comments or anything from the participants. So we have the first one from Ananya Tiwari. Yes, Ananya, you may go ahead, please. Is it from Ananya? Azad. Azad?
Hello.
Yes,
Okay. My question is, as Shweta ma'am was saying, that there are many different type of satellites, so the data can be projected, shifted from the real world. Okay. So if we use OpenStreetMap to help someone, so that would not be a problem. The shifted kind of data, the accuracy wouldn't matter in the help.
Okay, so when sorry, I thought your question was over.
Yeah.
Okay, so the thing is,
did you understand my question?
Yes, I understood your question. Thank you for your question. So the thing is, when there is a shift between imageries, the maximum shift is, I think, 10 meters, 15 meters, right? It also depends on what kind of resolution you are working with. So 10, 15 meters is the maximum shift that you will find. You won't find anything more than that. So that is that comes within the error criteria for us.
Shweta, I would like to add a few things on Ananya question, because that question is very important. Because Ananya, what OpenStreetMap does is, it has multiple different options which allows you to choose the satellite image. So for example, there is one satellite image that you can choose from Bing. There is another satellite image that you can choose from A3. And likewise, there are so many different satellite image base layers that you can choose from. And it's obvious that, different satellite images, they have different accuracy. So It depends on which satellite image you use as your baseline for while you are creating the vector layer on top of that. So I agree with your point that when user digitize on different satellite image, and definitely there is different kind of discrepancy. And talking about the accuracy of the OpenStreetMap, the accuracy of OpenStreetMap is directly dependent on the accuracy of the satellite image itself. So, higher the accuracy of the satellite image in terms of its geolocation, and higher the accuracy of digitization that is carried out, and the data set prepared on OpenStreetMap is also equally accurate, right? And as Sweta mentioned, normally like the shift is within that range, but you never know because you haven't done any ground validation of that data, right? So my personal experience has been in the context of several locations, it's not a good idea to consider OpenStreetMap location as the pinpoint accurate location whenever you are doing any disaster response activities. So it will give you, like a generic idea of, okay, this is where you need to focus in terms of location. But it's not the very exact precise location, because, that is something which is remotely digitized from a computer screen. So until and unless you get the data from real field, it's never an accurate location. So what I recommend is, if you are planning to work on any projects in the future, what you can also do is you collect the data from ground, you upload that data into OSM, and that's how you can enhance the accuracy of the OSM. Did I make it clear?
Okay. Yes, sir. Yes, sir. I was also asking about that too. That after response, the land imaginary would be changed. Sorry, after disaster, and most of the time we have no option to get the real time satellite data. So it would not be good to use the OpenStreetMap data for the disaster after disaster response purpose, right?
Yes,
If we
yes.
want,
Can I say something on this? So the thing is, for disaster response, what you basically need is the road data, right? Because specifically for the rescue team and relief team, right? So what happens is road data does not change whatever be the disaster, right? So you can definitely rely on this. But if you are specifically talking about what about the updates that we can provide during the disaster, because we cannot see the real-time satellite images. So the thing is, what we can do is whatever we see as devastation, right? Whatever we see, the changes we see in our localities is what we upload right then and then. So we cannot rely on exact real-time data on remote mappers.
And also one more, a few addition on what Sweta mentioned. So Ananya, it also depends on and the extent of disaster, and also how big the disaster is. Because if you look at Nepal earthquake, so what happened during Nepal earthquake was few days after Nepal earthquake, many satellite image companies, they provided high resolution satellite images for free of cost. So there was like companies like Digital Globe, those companies, they made high resolution data to OpenStreetMap available for free of cost. So in such situation, it is not possible for you or any other user to use the high resolution imagery. It's never real time. It would be near real time, like maybe if you 1 or 2 days after the disaster incident. But in case of localized disaster incident, for example, there is a flood in your community, then maybe in that case you might not get accurate data. So during time, what you can do is you can fly your drone, you can capture high resolution image with a drone, and then you can turn all that map prepared for drone into OSM, because OSM also has capability to that allows you to upload your own base map as well. So these are a few different cases beyond this one.
Okay, and what can I upload there? My own drone captured images or the ortho map itself?
And not images, also map.
Uh, like what can I should I if I want to enhance the accuracy of the OpenStreetMap at somewhere location, so should I use the directly capture raw data from drone or use the ortho
No,
mosaic
you cannot.
or any other kind of.
You can upload the imagery because the images they are only georeference. They are not a map. So images you cannot upload it for the mapping purpose. You need to create an orthophoto map first, and then you can upload it. But again, the big question here is you might be able to do the drone survey of a small area and then upload the orthophoto map and prepare a high resolution data. But how would you get a high
Hmm?
resolution data for entire India? You will not be able to upload a drone map of the entire country, right? So what organizations do is they collect the data from
Hmm. Sorry.
to validate and some data from your community. So yeah, just to give a straight answer to your question, you will have to upload the drone or the photo, and there are also other ways you can follow to enhance the accuracy.
Okay, sir. Thanks.
There is one more question on the chat box, so I will take it from the chat box. So the question is, where are the contour lines used? It is by Azad. So Azad, so as I mentioned earlier, the contour lines it gives information about the elevation of the Earth's surface, as I mentioned earlier. So the contour line that says 1500, it means the elevation of that particular location is 1500 meters. So any application where you need elevation information, contours are important. So if you are doing a roadworks project, you can use the information. If you are doing a road construction project, then maybe in that case, you can utilize the contour information for extracting the information of how much land area needs to be extracted, or how much land area needs to be filled. So any applications where you need elevation and height, you can use the contour information. Thank you, Ajay.
More questions, please?
If any of you have any questions, what we can also do, Ruchi, later on is I will share my email address, and they can directly contact us as well if you have any questions regarding testing applications or anything. We can also do that later on.
Sure, Uttam. We'll do that. So if there are no more questions, we'll close the session today. So once again, I would like to thank Uttam and Shweta for your generous contribution. And thank you everyone for your patient listening and learning. We will be having an assignment related to OpenStreetMap for today's session. And I hope you all do that very well. Thank you.
Thank you, Ruchi, for inviting us. We also had a great time interacting with everyone. Yeah.
Thanks a lot.
Bye, everyone. Have a good night.